Hi. How about the lecture on Chapter 8? Project Quality Management. You're going to find quality management something in your development career. It's going to be something at basically the companies you work for. It's going to be big. So why is it important? Well, we always joke about quality, and the textbook goes through comparison between what Bill Gates thought about the speed of computers and software compared to and the cost of computers to what cars were, what they'd be. And of course, GM, I think it was, came back and says, gee, would you want your cars to be not start, just shut off in the middle of driving? So there are definitely jokes about the quality of IT and software projects. Because I guess we're willing to accept things that happen on our computers that we definitely would not want to happen on our cars. But it is very crucial. There are several examples of major things that have gone wrong, from drugs to banking to data theft. And so it's big. So there are definitely some organizations out there, International Standards Organization. You may hear the term ISO 9000. All it is a set of rules that allow each customer to say, hey, I've got an outside agency that's validating am I doing what I said I'm going to do? Am I following the processes that I set up? It doesn't have anything to do with the accuracy of your processes, but it does have everything to do with, are you following the process you said you're going to do? Because quality is based on, am I conforming to the requirements, and is it fit to use? Would I use your software? So the three major phases in project quality management. It's the planning, performing quality assurance, planning quality management, performing quality assurance, and performing quality control. Now, planning quality basically means, hey, I need to think about anticipating a situation that could occur and then try to find ways to prevent it by either making sure that you got right materials, the right training, the people have the right mindset, how important quality is, and then making sure that the processes that the people are following allow you to deliver, create quality software. Different aspects from IT, from functionality to maintainability. So several different aspects to think about. Who's responsible? Ultimately, it's the project manager, but it's actually, most companies can tell you, it's each employee, from the receptionist all the way into the CEO, are responsible for the quality of their projects. There's a couple of organizations out there that set some organizations. So we saw one with the ISO 9000, but International Organization of Standardization, ISO, sets some rules and regulations, the ISO 9000, and IEEE sets other standards that allows you to develop quality projects. From project assurance, a quality assurance standpoint, there are several different methods out there. Quality assurance, Kaizen, lean, benchmarking, quality audits. I've done a few of these. Most of the ones I've been involved with has been between benchmarking and quality audits. Kaizen and lean are more on the manufacturing side, which I never had a lot to deal with, but they are out there. Controlling the quality. So I need to make sure that the outputs of quality control are, one is, when do I know things are acceptable? So what decisions have to be made when something's ready to move on in the process? What happens when things have to get reworked? What happens if we've determined in the process of developing something that the process doesn't work? How do I change it? And there are basically 5 tools out there that help with this. One of them is a cause and effect diagram. So it's making sure that, try to pinpoint exactly where in the process, what caused the error. You see it with airplane crashes. The NTSB is looking for what caused the crash. They're looking at every little nook and cranny, every piece of hardware, every piece of software, what the black box say. They're trying to peel back to the point where they know what caused the crash. Same thing happens with software or an IT project. I'm trying to find out who or what caused the problem. Sometimes it's your cause and effect, are called the fishbone or Ishikawa diagrams, and they're kind of known by the basic. You may hear the term 5 whys, and they're just kind of like a 2-year-old. Keep asking the question, why? Keep trying to peel back the layer of the onion to figure out what the root cause was. Now, another method is control charts, and that's just a graphic way to illustrate what are your processes over time. See more of it in a manufacturing environment, less in a software development, at least in my experience. 7 rules, just to say, I'm looking at if I've got 7 days where I'm not meeting my target, we need to look at it. We need to do some things. Another thing is a checklist. It's just a set of step lights. Your pilots have a pre-flight checklist to go through and say, hey, what works, what doesn't, and then go ahead and implement it. Scatter diagrams, I think you've probably seen them in PowerPoint, just trying to get a correlation between a couple of different data points. Histograms, same thing, based on different characteristics. I'm tracking information on each one and then proceeding to graphically display it because it's easier for humans to, most of us, to see a picture and get a quick grasp as to how things are improving. Pareto charts, known by the 80-20 rule, that most of 80% of our problems are caused by 20% of the things we do. So Pareto has it, and one of your homework assignments is going to actually, print one of those out. Flow charts, just a graphic way of seeing the whole process, giving you decision points, processes, and indicate along the way what parts that you would want to look at your process. Run charts. Basically, it says what's the history over time of how your processes are running. Statistical sample. When you're running a manufacturing line, you're not going to test every single piece. You're going to test a small sampling. But you got to determine what's a valid sample size. Well, mathematically, you can get the textbook goes back and say, hey, sample size is based on this calculation. But a lot is going to be dependent on your customer and what you're looking for. One of the major methodologies out there is Six Sigma. Very big. I've never had to use it, but it deals a lot with just give me the data. I don't care who, what. I just want to know what the data is telling me. So it's very disciplined on data, statistical analysis, and then using that data to go back and figure it out. Because they went down and says, hey, if I get to Six Sigma, and all that is 6 standard deviations away from the average, it's about 3.4 defects per million opportunities. There's a 5-phase process, define, measure, analyze, improve, and control. So it just gives them a way to try to keep analyzing the data. How is this unique? The training actually follows like a black belt, like a karate training, and it's white, orange, all the way brown, black. Project managers are usually black belt trained, but it's just a way of making this happen. Here we go, 6 Sigma standard deviation, 3.4 million. It has several tables to say, hey, how many defects would it be? But in the process, Six Sigma, look at 2 defects units per billion produced. That's not a lot of error. So it uses this to kind of validate the process and make sure you got that. Now, you may hear the system called 6 nines or 5 nines. But in telecommunications industry, 6 nines basically means I want service availability 99.9999% of the time, or 30 seconds of downtime per year. So it's just a way of saying how many faults can I have per million opportunities. Now, as far as programmers, most of the stuff that we're going to do, not that it should be the only thing we do, but it's one of the key things we do is testing. And there's 4 different types of testing that we do. Here we've got, unit testing, integration testing, system testing, and then user acceptance testing. Unit testing, basic, hey, this individual component, program, feature, function, does it work? Integration says, hey, now I've got the individual units tested. Do they pull back together as a larger product? Now the system says, hey, if, pull the whole system together. And then, of course, user acceptance says, yeah, just because as a developer I like it, may not mean the customer does. Maybe it doesn't meet their needs, which may mean that we haven't been in constant communication with them so they understand what we're developing. Now, here you're seeing people say, hey, software development testing is not enough. Because the systems are getting too big, too huge. So we need to say, how do I develop, error-free code at every stage so testing isn't there? Different quality management, different techniques, different experts I offered selections how to best do this over time. But it basically boils down, cost of quality does have a cost. Sometimes we say quality is free, but not necessarily. It's the cost of quality is, the cost of us conforming, meeting all the deliverables, and what's the cost of having to do the rework or things not meeting. And right now it's about $60 billion a year for the bugs that we're probably find in our software. There's about 5 different cost categories that you need to consider: prevention, appraisal, internal failure, external failure, measurement and test equipment costs, workplace, organizational impacts. But the biggest one, is I need a dedicated workspace. I need a quiet work environment to give programmers a better one. Sometimes that's why I see programmers with their headsets on and stuff. I don't know. Is that enough of a quiet workspace? To them, it works for them. Expectations and project management must understand all of this. But those expectations, based on the culture, based on the geographic regions, they vary. You're going to hear the term, maturity. Basically, that's just a larger framework to improve our process, and a couple of different models out there. PMI has this OPM3 model for best practices, capability outcome, key indicators, different types of software, spreadsheets, statistical software, Six Sigma software, project management with Gantt charts. I mean, there's plenty of different options out there. So hopefully this gives you the quick and dirty tool on quality. So hope it helps.